Good morning. Today we're talking about Sheetcam. Sheetcam is our CAM software. CAM stands for Computer Aided Manufacturing. This will allow us to take all of the different parts that we've made in our CAD softwares and turn them into something that we can actually cut. So it'll take our parts and turn them into G code that we'll then send over to Mach 3, and Mach 3 is going to go ahead and use that code to cut things out for us. This is a critical part of the manufacturing process. Let's dive right in. Today we're talking about the different views available in Sheetcam and how to navigate the screen. One of the first basic elements of navigating any screen is, of course, knowing exactly what your mouse can and cannot do. So let's go ahead, and first we can see that we have a red box in this middle of this screen here. By using our mouse, we can click and we can move around this red box, or we can navigate around the screen using our mouse by clicking and dragging. Alright. Next up we have the scroll button. The scroll button allows us to zoom in and out on our part. Now, all of these functions are only available underneath the pointer tool, or the view toolpaths tool, commonly called a pointer tool. Alright, so we can click and drag around the screen with our mouse. We can also scroll in and out to get our zoom function. Now, if we hold the scroll button, we'll notice that it'll allow us to turn the part around three-dimensionally. And if you find that you don't like this view, you can just double click on the screen and it takes us back to normal. So that's fantastic. Alright, and lastly, right clicking allows us to get into our zoom options, and we'll go ahead and cover that in a second. Also, right clicking allows us to measure parts, so we can click and measure, and we can actually measure out the size of a part based on different locations. We just click and drag to get out of the measuring. We right click and click end measuring. Again, this just allows us to double check our parts and make sure that our parts are actually going to be the size that we hope they are when we're working on the screen. So we can just click end measuring by going right click and clicking end measuring. Pretty obvious, but figured we'd go over that. Let's talk about our zooms. The zoom buttons are right here, but also available as we right click. Zoom in allows us to zoom in. Again, the zoom in button up here allows us to zoom in. The zoom out button, strangely enough, allows us to zoom out. Fantastic. Zoom to part, that is, if you have a part and it's selected on your screen, you can click zoom to part and it will zoom in on the part. The one next to it is zoom to fit job, and this is our job. So let's keep going from there. Zoom to fit material, that's our whole material. Zoom to fit machine, this is our whole machine, and we're going to go over how we can adjust those in the future. What this is a 4x8 material that I have on a 4x8 machine. So this fits our machine. We can also do zoom to fit window, which is just by clicking on the zoom to window tool, we can actually select the area that we want to zoom into, and it's going to zoom into that part of the screen, so you have access to that. So that's zoom to window here. And let's go ahead and go into our different settings for the red box. So to get to the red box, we go to Options and Job Options. This allows us to define exactly what our job area is going to be. And we do that by selecting the different size here. So let's say we were working with a 4x8 table, and our sheet, or the size of scrap material that we have, happens to actually be a 15 by 15 square piece of material. Okay, we can do that. Alright. Thickness of material, we can go ahead and set our thickness of material. However, it's only really an option when it comes to anything like routing or other types of depth operations. With plasma cutting, we're not going to be messing with thickness of material much at all. So I wouldn't worry about adjusting that for, your 11 gauge or 10 gauge or quarter inch or half inch material, 16 gauge. We don't need to input those manually into here. Unless, of course, we're doing depth operations, things like routing and milling on the system. The next portion is rapid clearance. Rapid clearance is the safety distance that the torch moves vertically upwards between every cut. So it finishes a cut, lifts off, moves to the next cut, drops down, and begins its next operation or next cut in the operation. That distance is defined by rapid clearance. This keeps your torch away from things like tip-ups or other sorts of things that can happen mid-travel. Again, the system's going to be moving faster when it's doing its rapids, when it's moving from a position doing a non-cut movement. So rapid clearance, the higher it is, the more safe you are, but however, the higher it is, the longer it's going to take to move in between each cut. So it's a variable that you're going to have to look at. Most of the time we keep that at 3/4 of an inch because it is a safe distance for most of the operations you'll be doing on your system. So keep that in mind. Rapid clearance is a safety motion. Again, the higher it is, the safer you are, especially if you're going to be walking away from the table for any length of time while the system is cutting, and you don't know your part well enough. Having a higher rapid clearance is going to save you almost every time. Now, height of the bottom of the material above the table, that's something we're only going to deal with when we're dealing with routing, so don't worry about that in this case. In plunge safety clearance, we're not going to be worrying about that in this particular setup. Now, if you want to save any of your setups here, you can also click Save Material. This is just if you happen to be cutting standardized sizes, like if you're constantly cutting this 15 by 15 rather than manually inputting all of this, you can always just go ahead and click you save material, and then when you deal with this same size of material, you can hit Load Material and it'll load up all of your presets for that. All right, another part that we're going to bring up here is parking. Parking allows the machine to return to a given location after it finishes cutting. It parks the torch in a specific location after you're done. You can consider doing that. It's a feature that a lot of customers are, let's say, on the fence about. Some love it, some hate it, some use it, some don't. So I will leave that up to you. If you like your torch to return to 0 at the end of your cut, please feel free to click on Use X, Y, and Z, and that allows the torch to then come back to 0 at the end of your cut. However, I will say that the only possible negative to this is that if it is returning to 0 and you have multiple tip-ups, there is a higher chance of it hitting those tip-ups on the way back. So I would recommend turning those off if you're afraid of that being the case. All right. The rest of these we aren't going to be discussing here because we're not going to be doing any tool changes, and likelihood is you're not going to be running any remnant cutoff immediately. As we get further into the program and as we do more advanced videos, you'll see access to these different parts. However, we're not going to be dealing with these currently. We'll be dealing with those in a later video. All right, the one last thing I want to say when it comes to material is we can also talk about the origin. The origin is the bottom left-hand corner of your material. You're always going to want to set it to that because that's how our machine is based. That's how we run our machines. If you want something different, we can definitely talk about that on a one-on-one basis, but 9 times out of 10 we're going to set our origin in the bottom left-hand corner. That's going to be our 0, 0, and that's how we're going to home or set our 0 on our material when we go to cut. So we're going to make sure that that is the case. If we were to change that around, that does change part placement and a couple of other factors. Keep it here and we will all be on the same page when we're making our cuts. With that being said, we can go ahead and hit OK. And there we go. We've changed our system here. Okay, let's go ahead and talk about this gray area. This gray area is known as your machine. Now right now it's set up to a 4x4. We can adjust that. Actually, you know, it's smaller than a 4x4 there. We can adjust that by going to Options, going to Machine Options, and we can set that up. So your working envelope is going to be the size of the workable area of your machine. In this case, we're going to go ahead and set it to 48 by 48, and you'll see that the actual background, that gray shape, changes. However, on a 4x8 we go to 96. Fantastic. So this allows us to see exactly what our table area looks like in relation to if we're going to be cutting something like a full 4x8 sheet. On our systems, you're not going to have a machine coordinate 0, so this isn't as applicable. However, if you do want to see your machine area and take that under consideration, this is a good way to do it. It also provides another added layer of safety if you're constantly bringing in your material and zeroing out at the bottom left-hand corner of your table. Again, options for you, not a necessity, but we recommend at least having these values input for future uses. All right, fantastic. Same thing. I'm just going to change out our table display to 48 by 96. All right, all the origins, every origin that we work with is going to be in the bottom left hand corner. Post processor here. This is our post-processor screen. This allows us to A, make sure that we're in inches, B, we have an output folder. This is a folder that we're going to be saving all of our G-codes to. We have a folder on all of our systems called Mach 3 G-code files, and 9 times out of 10 you want to save it right there because you know that all of your G-codes will be there when it comes to running Mach 3. So you'll always be able to go back to that folder every time you process a file and go, my files are right here, and you don't have to go searching for them because time is money, and searching for a file is certainly not a way that you want to spend your time. Okay, moving on. The final bit here is our post-processor. Our post-processor is going to determine a lot of different rules that are set up within our systems. So this will be where your floating head operation is also going to be included into your code. This is how our machine gets paired with this software. Without this post-processor, our machine, the actual table itself in the Mach 3 system, won't recognize the cut file properly, and you'll likely ruin a good sheet of material by not having the correct post-processor. Now we have 3 different post-processors available. We have the latest update on the post-processor. That's the Write CNC Pro Kit edited. There's also a 1217, and they're essentially the same file. We have another file called the non-float. This removes the floating head operation for those of you who want to do operations where it's not touching down onto the material and lifting off. So if you're doing a lot of thinner material, you don't want to run into that touch-off sequence, bending that material, forcing that material downward as it touches the material. All right. And then we have one called a constant touch-off. That is every time the machine goes to make a pierce, it's going to come down, touch the material, lift off, and it's just going to do that every single time, as opposed to this current post-processor, which will do it intermittently throughout the cut based off of a given set of criteria that's coded into this system. So keep that in mind. Our post-processor is one, critical for actually running the machine, critical for actually coding the G-code, and then of course the post-processor is there to allow for different types of cuts based off of what type of tooling you're going to be using on your machine, whether it's a router or whether it's a plasma. And again, 9 times out of 10, we're just going to stick with the post-processor that's available there, unless of course you have a specific reason not to use that, in which case you can reach out to us directly and we can talk about that. But that's enough about that for right now. We can go ahead and hit OK and leave that there. Let's break down a little bit more about what we're seeing on the screen. So we have a series of tools up here on this part of the screen. We have our pointer tool, our start tools, edit start points, edit tabs, edit contours, nesting, align, action points, simulation, and text. We'll go into each of those later on in some of the other videos. We're not going to talk about that specifically right now. Next up, we have on the left hand side of the screen, we have a portion that's labeled parts. Parts is where all of the parts that we have uploaded onto this Sheetcam file will be found. So if you find yourself, you know, what parts do I have, you can always go up to this list. We can always use that as well to select the individual parts that we want to work on. Just below that is our tool sets. Now your screen may show a slightly different set of locations of these different portions, so keep that in mind, but you will have parts, tools, and operations on the left hand side. The tool screen allows us to see the various tools that we have available to us. We can also build custom tools into Sheetcam that'll fit our different jobs operations as we're going forward. So all of your tools will be listed here for your plasma cutter in this case. And then underneath that is the operations screen. If you see more than one operation, you're probably doing something with layers, and we'll talk about that on another video. But all of your operations, so every one of your cut systems, your cut operations, will be listed under operations. So take a look down there and it will change per part. So if you select a part, it will show you the operation that's associated with that part and list it down here. So there you go. That's the basics of the views on the screen. We're going to go ahead and break down into another video that talks a little bit more about bringing in parts and what you're expected to see when you do bring in a part, as to what all of these colors mean, so on and so forth. So let's go ahead and break off into that video next.